In this video, I'm going to discuss a few things. The first one is an alternative method to drain the coolant from the system, which is much cleaner, it's much quicker, and you'll get about 95% of the coolant out with just a little bit left up the front of the car. I'll also give some guidance on how to achieve the best vacuum that you can with the tool that you're going to use to get the most coolant into the system when you're filling, because for mine that is probably the most important part of the process, to have as little air in the system as possible. And then finally I'm going to talk about simulation of the PWIS bleeding mode for the cooling system. A number of years ago I made a video that gave some guidance, and now after playing with this for a number of days and multiple fills and drains and looking at what PWIS actually does and the control valves it opens and closes and that sort of thing, I realise now that what I put up previously wasn't exactly right, and I'm going to show you probably a much better way of simulating what PWIS does. It's not exactly the same because you can't really do that, but it's as close as you can, and I get exactly the same results when I bleed the system. I'll go through a diagram of how the system works, because we're going to disconnect some vacuum lines for the control valves to make sure they're open when they would otherwise be closed, etc. So that'll take a fair bit of time, but in the end you'll be able to quite happily bleed the system without using PWIS and get exactly the same results. I've been playing around with the cooling system on the car because one of the things I really wanted to work out was a better way of draining the system. Because when you drain from where they suggest in the workshop manual, which is here and over here, you get about 5 or 6 litres out of it. You don't drain the transmission cooling pipes, which is something that I wanted to try and do. But also most of it is still in these big pipes here, and when you disconnect the pipes here, it then really gushes out. It's really hard to control. You end up with it all over the floor, etc. And the same up the front with the radiators where you disconnect those. So what I wanted to do was come up with a system that worked better than that I could collect it all and get rid of most of the coolant out of the system without having to disconnect these pipes. And so what I ended up coming up with is a system where you can initially drain out of these two. You then apply gentle compressed air to the expansion tank, to one of these at a time, very gentle compressed air, like no more than about 15 psi. And then that just blows it all out, and I was able to get most of it out. And then if you disconnect this pipe here, then you get another litre out, and in the end you evacuate pretty much 95% of the system. You don't end up with a whole lot left in there, and most of that is just at the bottom of the radiators up the front. So depending on what you're doing, you may want to disconnect those. There's a little bit in this pipe here, but apart from that, it's a very simple and quick way of draining the coolant, so you don't end up with it all over your floor, and you get most of it out, so you can easily work on stuff back here without having to drain and disconnect these pipes here. So I'm going to first drain from here, make sure the cap on the expansion tank is off, just so it can drain out. When you're draining from the plastic plug here, the way this is designed is there's a slot in it, so as you pull it out, it allows it to come out of that little slot. The problem with this, especially when there's a little bit of coolant inside, is that it just wants to shoot out sideways and you make a bit of a mess. So I would suggest that when you loosen this, you'll notice that when it starts to drip out, you'll actually see that where the slot is, because it'll rotate round and round and round. And what you want to do is have that, so it's about maybe ½ a centimetre out, and that slot is just pointed down. And then it'll just drip out. It'll be fairly slow, but it'll stop making a complete mess. Now once it slows down to a dribble, because there's not much coolant left inside, then what we can do is release that a little bit more, and it won't shoot out sideways, and we can get the rest of it out of there. And once it starts to do this and sort of glugging a little bit, you don't need to wait for everything to come out, because we're going to blow that out in a minute. We can cap that off. Big thing with this is you don't want to do this too tight. Just seat it firmly, and that's it. Now I'm going to open up this one again. There should be very little come out of this now, but this is where we're going to blow most of the stuff out. So what I'm going to do now is go and apply some compressed air at a very low pressure at the expansion tank. What I've got, this is a fitting from a radiator test kit that just fits smack bang where the normal radiator or the expansion tank cap fits. Normally you would put a little pressure connection on there. And what I'm going to do is apply compressed air to it. Now what I've done, and this is really important, is I've turned down my air compressor. So it's only pumping at about 15 psi. And what I'm going to do is with that fitted, I'm going to gently put that on there, and it's not going to be perfectly sealed, and I'm just going to blow, and it's amazing how much more coolant will come out of that. You see, I think I've got about 5.5 litres there at the moment. We'll see how much we get out of it. So applying air now. And what I'm going to do is cap this off, and we're going to do the same thing at the other fitting. And to blow some air through this fitting, once we have done the other side, what I'm going to do is firstly, because there's going to be some coolant there, I'm just going to let that drain until it's just a dribble. I'm going to remove the cap. And then I've just got a piece of 6mm hose, which is about 9mm outside diameter, and that fits perfectly into that once we remove the screw. And obviously if you apply compressed air to this and going sideways, just make a complete mess, whereas this just points it straight down into your bucket and it collects it all. And to get a little bit more coolant out, the connection next to the screw fitting here, that pipe, if you remove that clamp, you don't actually have to even remove the pipe. If you just get your plastic pry tool and just sort of jam it in there so it creates a gap at the bottom there, it'll just all dribble out. And it saves you making a mess, and that can be easily just collected in your bucket. And I've got about another litre doing that. So after draining the coolant from that point there and that point there, and then one at a time, pushing it out with some gentle compressed air at the expansion tank, and then disking that connection pipe there and allowing it to dribble out. I then went and disconnected where it says to normally drain the coolant from. In this large pipe here, nothing came out, basically a dribble, maybe a millilitre or two at most. This one here, there was a little bit of residual in the bottom of that pipe, maybe 50 millilitres came out. I got about half a litre out of the right radiator and about maybe 100 millilitres out of the left radiator. And in total, that's what I've got, which is a bit under 750 millilitres total that was left in the system, mainly at the front, after just removing the coolant from those 3 connection points. If you do want to disconnect these lines just to get that last little bit of coolant out, a couple ways you can do that. You can disconnect it at the connections here. To do that, there's a little hole here, push a screwdriver up through that. That clip there that holds onto the hoses will come out to the front, and then you can remove those clips and disconnect those. Or alternatively, you can just remove the clips here and then just wiggle these pipes out, and it's doing exactly the same thing. Same thing over here. And when you're reinstalling these, just fit the clips first so they're in the correct position. Make sure you grease the connection points and the O-ring on the inside, and then just push it in, and that'll just click into place. If you do want to drain the radiators at the front, you'll need to remove the wheel liners. And to disconnect these bottom pipes, just remove the clip with the pick tool, and you can wiggle these pipes free. They'll be a bit stuck, so just get a screwdriver in here. Don't just lever it out, just turn it gently as you wiggle here, and these will come out quite happily. And once it's disconnected, you've got your bucket underneath, lower the hose down, and then there's a clip underneath here that's designed to hold the hose in there so it points down so it can drain there. And once you've finished the draining, to connect these pieces, put the clip in the correct position like that first, grease up the connections, And then you can just push the hose in and it'll just click into place, and then give it a good wiggle once you're done, just to check it's secure. So when you are making the vacuum inside the cooling system, this is the technique that works best for me. My air compressor I have adjusted so it cranks all the way up to 120 psi. It'll kick back on at about 90. And what you'll notice is that if you press this and achieve a vacuum at 90 psi, it will be significantly lower. It'll probably be around 24 or 25 inches of mercury. Whereas if it's right up at 120, it'll be close to 27.5 or so. And that's going to make a big difference to the amount of air that is residual inside your system and how much coolant you're going to be able to get into it. So what I would suggest you do is when you initially start, just let the thing run, but then when it gets close to settling down, just stop, allow your air compressor to run up to close to the maximum it's going to do, and just before it kicks offline, then start to allow the air to go through this again. And hopefully it should just hold just below or right at the maximum pressure that you've got, and then you should be able to achieve the best vacuum you can in the system. And so what I did was I allowed the compressor to build up to just before I was about to cut off, so it's sitting here right at 120 psi. I put a clamp on the button there, just shoved that in there. I just walked away for a minute or two, and when I came back, the compressor, when I took it off, stopped about 2 or 3 seconds later, so I was right on the cusp of cutting out, and I've achieved about 28.5 inches of mercury vacuum there, which is, mate, that's pretty good. And I did some calculations, and for every inch of mercury better that you get on your gauge is going to be the equivalent of about 600 mils of air in the system less. From that, I should be able to get a total of only about a litre of air entirely in the system. Something else you can do to purge your lines of coolant before you fit it here, have your bucket at about the level of the fittings here, and then you can push your hose down into the bucket, fill everything up, put your finger over the end of the hose, and then put it in here, and then just quickly fit it. That's why I've got a rag under there just to catch a few drops if they spill out. And now I've pretty much got an entire line full of coolant prior to opening up the valve. And to give you a bit of an idea of how effective that filling method is of really getting a good vacuum, when I filled this after doing the initial filling, it was up to about there, and after the full bleeding process, it's dropped about 1 inch. So that's all the air that was in the system that's come out. And that was exactly the same whether or not I used, because I did this multiple times, whether or not I used the PWIS bleeding method or the method that I came up with. With your vacuum filler that you use, really important that these are clean. This is an airlift unit which I use, and it's bloody fantastic. But to clean these out afterwards, because you're always going to have coolant inside, and the next time you use it, if coolant's dried, the venturi and the vacuum part of it isn't going to work as well. So what I do is I just open everything up. I'm going to shove that under a tap like that. It doesn't have to be high pressure. You just want running water going through there, press the button, and then water is just going to come out of everywhere, and it's going to blow everything out. And then what you can do, come and put some compressed air on it, and then have everything open and just sit here and just run compressed air through it. It might take you a couple of minutes just to clean and dry everything out, and then it should work really well. And then when you go to use it next time, then you should get a decent vacuum. The vacuum that you're trying to achieve, you should be able to get this just by putting your finger on the bottom of it, press it, and that's what it should go to. So that's the vacuum that you should be able to achieve when you apply this to the car if you use the correct technique. This is a basic image of the way the cooling system works in the car. You've got the pump. It's going to pump fluid into the engine. It goes in the bottom of both heads, comes out the top. And then when it comes out the top, there's a big sort of a Y-shaped coolant pipe, which is made of aluminium on the front of the on the engine. It gets split into two there, and that allows it to either go back to the pump and go round and round and round, or allows it to come up to the radiators to get cooled. It also goes via some pipes on the underside of the engine. It sort of goes above the oil pan on the right hand side underneath the engine, and then it comes up the back of the engine. It gets split into 3 places there. It can either go forward to the engine oil cooler, and it can go rearwards to the clutch and gear fluid coolers on the transmission if you've got a PDK, or just gear fluid if you've got a manual. It also has the heater core, so the hot coolant that would have come out of the engine as it's coming up the front here can come off here, go to the heater core and get warmed for your cabin, and then it just goes back to the pump from there instead of going to the radiators. The different things are controlled by valves, and that's what these blue dots are here. And they are controlled by vacuum. So your engine has got a vacuum pump which goes to lots of places, and one of the things it does is it controls these valves, and these valves have a solenoid and then a bellows attached to them. So with the bellows, it's allowed to contract if the solenoid is activated, and when these are activated, it closes off flow. So it's important to note that if there is no vacuum or no power applied to either the solenoid or to the vacuum to the bellows, then it allows coolant to flow, which is exactly what you want, because that means it's fail safe. So if you have some sort of a failure, then cooling flow is still going to continue. So when you first start the engine, what does it do? If you have the heater core, so it's not being activated, so that would mean that you just have the air conditioning off, or it's a hot day and you've got the air conditioning on, then this valve is going to be activated so you don't get heater core flow. This valve here, which is the one on the front of the engine, this is going to be activated, and what that does is it completely stops the fluid going around the engine, and the idea of that is to, as rapidly as possible, warm up the engine. And the 2 valves for the gear and the clutch fluids also are closed. So they're all activated to stop any coolant flow. And so what's actually going to happen is you will get coolant flow from the pump up to the engine oil cooler, and that's going to rapidly warm the engine oil as quickly as possible. And if you had the heater core operating because you've got the heater on, then it would allow some fluid to come through to the heater core. But other than that, there's very little going on. This one here, I don't exactly know when this is programmed to open again to allow coolant to come back here. I know if the RPM gets up to about 3000 RPM, it automatically opens that so it doesn't put too much strain on the pump, etc. But as far as what temperature it opens normally, I don't know, but certainly by the time you get up to engine operating temperature, what's going to happen is obviously this is going to get nice and hot. The coolant flow that is coming back to the pump gets hot enough to open up the thermostat, and that will then allow flow coming around this way to go through the radiators and then back again via the thermostat to the pump. For the transmission fluid coolers, these open when you get pretty close to 90 degrees or so. The clutch fluid opens first from what I've seen, the gear fluid a little bit later, but the engine has got to be pretty much warm before these start to warm up. In addition to that, we have these bleeder lines which are sitting on the top. There's one on the top of each radiator that goes to a single line that goes back to a bleeder valve on top of the expansion tank. And then there's also one when these pipes come up the back of the engine and split off to all the different coolers here. There's also a bleeding point there to get the air out. And that bleeder valve, which sits on the top of the expansion tank, that is normally closed, so it's not going to allow air to come out of that or coolant. But when you're bleeding the system, what it does is you open that deliberately, and that will allow air to be purged out of these high areas so you can get all the air back to the expansion tank and get it out of the system itself. The expansion tank, it sits up the back left of the engine bay. It has the bleeder valve on the top. It has the cap, which is the pressure control valve, and then it also has a line pipe which goes to the filling port, which is under the rear lid. It has a connection point here which runs down on the connection points to the engine oil cooler, which then allows coolant to flow into the entire system when you're filling the system. And finally, there are 2 temperature sensors in the system. There's one here on the return pipe from the radiators, so the radiator outlet temperature, and there's one here on the back right of the engine. This is the one that gives you your temperature inside the cabin, whereas this is the one that controls how much the radiator fans turn on and that sort of thing. So what does the coolant bleed mode in PWIS do? Well, the first thing it does at idle is it's going to open up all of these valves to open up all these lines. Okay, so normally when you first start, and if you don't have the heater core running, they would all be closed down. Well, it's going to open all of those up. So fluid gets passed through here and it cleans all of the air out of it, out of the high points, and in the heater core as well. Then it automatically, once the coolant temperature gets to 60 degrees Celsius, it raises the RPM to 1500. And then also what it does is it deliberately opens the thermostat, and it does that by sending electrical power to the thermostat, which heats it up and opens it. Now, it would normally never open at such a low temperature, but that's what it does. And the idea is with that raised RPM, it's now going to pump more fluid up this way to pump it out of here. In addition to that, because we had the bleeder valve open, it's now going to force the air out of the top of the radiators, and it's also going to force it out the top of the connection point at the back here. And once it gets to 85 degrees, the bleeding mode stops. And so by that stage, the assumption is that all of the air has been purged out of all of these high points. It's all got back to the expansion tank, and your cooling system is all good to go. So how can we simulate that coolant bleeding mode? Well, what we can do is we can easily deactivate these so these are open, because they would normally be activated and fully closed when you first start the engine. And what we can do for those is for that one, and that one, we just need to disconnect the supply of vacuum to them, and I'll show you how to do that. So the solenoids connected to all of these, they'll activate fine, but there's just not going to be any vacuum connected to them, so they won't actually move, and that means that they will remain open the whole time. For the heater core, all you need to do is just turn your heater on, so put the temperature to high, just put it on a really low blower setting, and that will open that the whole time. So by doing that, we have all of these four open, which is exactly what the bleeding mode does. The only other problem we've got though is that I need to somehow open the thermostat, and I don't have the ability to open it at 60 degrees like they do. However, what I can do is I can wait until the thermostat opens naturally, and I can lower that temperature by selecting sport mode. And by selecting sport mode, it changes to what they call a set point temperature. And the set point temperature is the temperature at which this is trying to aim to achieve. Normally that's 105 degrees when you're normally driving around. If you select sport, it changes, it'll lower, and depending on what you're doing with your right foot, it'll change that. From what I've seen, I could quite happily get that at 2000 RPM down to about 90 degrees. So what we can do then is I can raise the RPM, and that thermostat will open automatically at about 90 degrees, and then at that raised RPM, it will pump that fluid around quite happily and purge the lines of air. You're probably asking the question why I'm using 2000 RPM instead of 1500, which is what the normal PWIS mode uses. And then what I found was at 1500 RPM, there didn't seem to be enough pressure to pump it out of both of the bleeder lines from the front. When it goes up to the front, obviously 2 radiators, some cars have 3, but the right radiator is the one which is closest to the pipe. This pipe that's going up this way, it runs down the right hand side of the car, so it goes to the right radiator first, and it seemed to purge out of here quite happily. However, the left hand one, there wasn't enough pressure to push it over the other side and push it out of the left one. As soon as I raised it to 2000 RPM, that started to do that fine. So for mine, I'm just going to use 2000 RPM for all of this once the temperature gets up to about 60 degrees, and then that should quite happily push the air out of both of those radiators. So the way I'm going to do the whole thing without using PWIS is I'm going to start the car from cold. Prior to starting, I'll make sure that the heater core is going to be turned on just by selecting a high temperature. I won't have the air conditioning selected on. I'll deselect the supply lines to these for the vacuum, and I'll show you how to do that. and then I'm going to open the bleeder valve. I'll start the car, let it run up to about 70 degrees in the cockpit. Actually equates to about 60 degrees coolant temperature. And then once I do that, I'm going to put a stick on the throttle, raise the RPM to about 2000, and then allow that to continue. What you'll notice is that the temperature rises really, really slowly. Unlike what it normally does, because it's all the fluids that are jammed in here and not moving, because it's now circulating through all of these coolers, the temperature should rise really, really slowly. It's surprising how long it takes to get up there. What you'll notice is as the temperature increases, because now we've got fluid being pushed here, it's not coming back this way because the thermostat's not open yet, is that the lines here, the bleeder lines, will start to get warm. So we should feel that the supply lines start to get really hot. Okay, so that's the lower right one and the upper left. They should really heat up. The return lines should stay dead cold until the thermostat opens, which is going to be much later. And I'm going to allow that to run at 2000 RPM. It'll take 10 or 15 minutes for the temperature to finally get up to about 90 degrees. And when it gets up to 90 degrees, I'm going to take the stick off the throttle, bring it back to idle. I'm going to turn the engine off, and then I'm going to reconnect the vacuum supply lines here. So everything's back to normal. I'll close the bleeder valve, and then what I'm going to do is start the car, select sport mode to lower that set point temperature, and after that I will start the car and put my stick on the throttle again, raise the RPM to 2000 and allow it to slowly get the temperature up. It'll still take another 5 minutes or so. Even though you see 90 in the cockpit, that's still only about 80 degrees, and it'll take a good while, another 5 minutes or so, for it to get up to sufficient temperature to get the thermostat open. And then once the thermostat opens, what you'll notice is that very rapidly, there's a funny thing that happens is because now this opens, and very rapidly I'm going to get this cold fluid from here run to the engine oil cooler. You'll see quite a distinct drop in the oil temperature on your instrument cluster, and then it will slowly start to rise again. But also if you grab hold of these return pipes, they will start to get really hot. So before they were dead cold, they will now see the radiator return fluid, which is now going to be pretty hot. And after that, I'm just going to let it run for about 10 minutes or so. I'm going to watch the temperature really, really closely to make sure it doesn't get too hot. But if I'm getting return fluid here, then I know that I'm getting good flow throughout the system, throughout the radiators, and everything should be good to go. And I'm going to run it for about 10 minutes or so, try and purge as much of the air out of the system here at 2000 RPM. And then indications are all good. Then I'm just going to give it a bit of a thrash to check that the cooling system is all fine. Here's a pretty rudimentary explanation of how the solenoids and the vacuum operated valves for the cooling system work. Your valve, which is this one here, there's going to be a pipe that allows vacuum to go to that. There's going to be a solenoid with an electrical connector there. And then there's going to be a vacuum supply line, which comes from the vacuum pump from the engine. So the way these work is that if vacuum is applied, it makes a bellows contract, and that bellows contracting then will stop the flow going through the coolant pipe. To try and trick the system into thinking that it's going to bleed the system, we want to deactivate these. Now what I don't want to do is pull the electrical connector off, because that's just going to give me errors and that sort of thing. What I'm going to do is remove the supply line of vacuum and plug it. So I'm going to go to the solenoids, and for the one on the front of the engine, and I'll show you this in a moment, I'm going to disconnect from the supply line, and I'm going to plug it. I'm just going to use a golf tee. These are golf tees with the skinny stems, so I've just had to cut those off so I get a bit fatter, and you just plug that like that, so the vacuum here remains, and it doesn't allow lots of air to be sucked in, so it doesn't give you errors for that. The solenoid activates, but obviously no vacuum gets to the bellows, so the thing doesn't activate, so we constantly get the flow through the pipe, which is great. For the two for the transmission, there's a supply line. There's two of these that sit on top of the transmission for the PDK. They go into a wire to a single joining piece, and then the pipe goes underneath the inlet manifold to the other side. And I'll show you where this is. So instead of disconnecting at the solenoids, we're going to disconnect it up here where there's a connection piece, and I'm just going to plug it there. The solenoid for the valve that sits on the front of the engine is this one here. The supply line is down the bottom here. The easiest way to get access to this is just to pull the solenoid out. There's a little clip there, you just pull that to the left, pull it up and out, and it's this one here you want to disconnect. You put that back on there if you want, so when you're doing the start everything's nice and secure. But then we want to plug that one there. For the vacuum line that goes to the solenoids for the transmission cooling, that's this one here that goes underneath the intake manifold. So I'm just going to pull that off. Now these are really hard to get off to start off with because they're just shoved in there in the factory and they've been sitting there for years. Once you finally get it off, and it'll take a fair bit of effort, I would suggest just getting a tiny bit of grease and just smearing it over that. So it's going to be easier next time. They're vacuum lines, so they're not under pressure, they're going to suck together, so it doesn't really matter. And then I'm just going to put my golf tee in there. So the supply line is plugged, but that one there now is open, and so the two solenoids at the transmission won't get activated. And so to do the coolant procedure, I have actually filled it up with coolant. I've put the cap on the expansion tank. I have lifted the bleeder valve clip here, so that's all open. I have disconnected the vacuum supply lines and plugged those on this one here as well as the one at the front here, and when I start the car I'm going to put the air conditioning, I'm going to turn the air conditioning off. I'm going to make sure the heater is on high with just the lowest fan setting, and then everything's good to go. I'm going to start the car. So the temperature is approaching 60 degrees on the MFD. I can feel a little bit of heat coming through this bleeder pipe here, which is the one from the back of the engine, which is what I'd expect. The one here, not so much, because that's the one that comes from the radiators, and I'm really only going to get that stuff pushing through there once I select 2000 RPM. So the coolant's got up to 70 degrees and I've just selected 2000 RPM. What immediately happened was the temperature on the MFD for the coolant dropped by a couple of degrees, because now that coolant has been pushed through the radiators and back through the bleeder line here. This is starting to get warmer. I can feel a little bit of warmth in this hose here, meaning it's coming out of the radiators at the other end. And also if I go to the supply pipe, which is the lower one on the right or the upper on the left, I can feel there's heat coming into those, but the return is cold because obviously the coolant isn't coming back through those. Also what's interesting is on the MFD the coolant temperature is rising very slowly. It's taken maybe 5 minutes to get from 70 to 74 degrees because that coolant is going through the radiators, which is exactly what you want. The coolant temperature has now reached 90 degrees. I've turned the engine off, and so what I'm going to do is reconnect the supply lines for the vacuum. I'm going to allow the bleeder valve to go down. When I start the engine, I'm going to turn the air conditioning off, so the heater core valve is definitely not open. And then I'm going to select sport mode. And when you select sport mode, it'll actually only really get into sport mode at a certain time, and it seems to be when it gets up to a certain temperature. And you'll know that when you get that change in engine note where it starts to get that low burble and the idle RPM jumps from about 700 to 800. That's when it seems to be when the set point temperature of the thermostat will change. And when you select about 2000 RPM, that set point temperature will be about 90 degrees. So soon after I select 2000 RPM sport mode, once the coolant temperature gets to 90 degrees, and even though it's showing 90 degrees now, it's actually only about 83. I don't know why it's like that, but it'll take a minute or two for it to get to 90. And when it does that, then what you should feel is the return lines of the radiators now start to get hot. So I've just finished the bleeding of the cooling system. Once I got it up to temperature and everything seemed to be stable, I ran it for about 10 minutes just to check that the coolant temperature wasn't going to go up, and the oil temperature was nice and stable, which it was. Gave it a whole bunch of revving just to check that nothing was going to overheat, so that seems to be all fine. One thing I did notice though is once I started it again after connecting everything and putting it into sport mode, is it took about 5 minutes or so for the thermostat to open. And probably the thing that showed me that it was open was the oil temperature had quite a significant drop in a short period of time. So I could drop my maybe 6 or 7 degrees over a couple of seconds. And I can only assume that is because as soon as the thermostat opens, there's a whole bunch of cold fluid that is being fed now to the oil coolers. So you get this quite rapid oil temperature change down, and then it starts to work its way back up again. But that seemed to be the indication that the thermostat had opened, and then immediately I could go and feel the return pipes on the radiators, and they were really hot.